Hello friends, myself Ravi Thakur. Welcome back to Techno Education Academy. In this video lecture, we will derive expression for rate of flow through orifice meter. First of all, what do you mean by orifice meter? It is a device used for measuring the rate of flow through pipe. It is a cheaper device as compared to venturimeter. It is a cheaper device as compared to venturimeter. As you know that in the previous video lecture we will derive the expression for rate of flow through venturimeter. So, and it is easy to derive the expression for the rate of flow through orifice meter of the discharge, because it works on the same principle. Now, generally we will derive for the pipe flow, and it is used for the measurement of the flow. Now, here I draw the schematic representation of the sketch of the orifice plate or orifice meter. It's like that. There is one pipe. And here I put a orifice plate. Is the orifice plate, and this is called area of vena contra. The section 1, here the section 1, here the section 2, and in between there is a manometer. Look at the manometer. Or there is a manometric difference or height h between the manometric fluid. Here the direction of flow is like that. This is pipe, is this orifice plate, and it is called differential manometer. Now, at section 1 and 2, similar working principle like venturimeter. So at section 1 and 2, we will apply Bernoulli's equation. So we can write down here P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2. Now here nothing but P1 is the pressure at the section 1, V1 is the velocity of the fluid at the section 1 and Z1 is the piezometric head at the section 1, or Z2 is also the datum head at the section 2. So Z2 here in our case Z1 is equal to Z2. So we have neglecting the datum head term. Now we can write the further simplified equation like that: P1 by rho G plus Z1 bracket minus P2 by rho G plus Z2 bracket over is equal to V2 square minus V1 square by 2G. But in this case Z1 is equal to Z2. So we have neglecting the datum head term Z1 and Z2. So we can write the equation like that: P1 minus P2 by rho G is equal to V2 square minus V1 square by 2G. In the previous video lecture we have already derived this pressure rate term in the form of H. So we can write H is equal to P1 minus P2 by rho G is equal to V2 square minus V1 square by 2G. Now V2 square minus V1 square is equal to 2G H. Further simplifying that this equation, so V2 square is equal to 2G H plus V1 square. Now under root V2 is equal to under root 2GH plus V1 square. It is called equation number 1. Now the main fundamental in this case is like that. Here I can draw second time the vena contra because it is important for you. What do you mean by vena contra? It is a pipe. Okay. In this pipe there is a orifice plate. Here this is called the vena contra and it is called the area of vena contra. Or for that this is the contraction happens. What happens? Here contraction happens. Contraction of area. So this here we can add one technical term. It is called coefficient of contraction. It is called the CC is equal to, here the section 2 is there and here the section O, it means orifice section. It is called orifice section. So here there is an area AO. Here the area AO. So it is called the area of orifice AO. So the coefficient of contraction CC, we can write down this equation. CC is nothing but area of vena contra. It means at A2 it is called the contraction area A2, area of vena contra A2 divided by A0, area of the orifice meter or orifice plate. So CC is equal to A2 by A0. Now we can subject A2 is equal to A0 CC. It is called the equation number 2. Now further simplify the equation and apply the continuity equation at section 1 and this is section 1, you know, this is section 2. Apply one continuity equation at section 1 and 2. A1 V1 is equal to A2 V2. Here V1 is equal to A2 V2 by A1. Put A2 is equal to A0 Cc in this equation of V1. So A0 Cc V2 by A1 is equal to V1. Put equation number 3, the value of V1, in equation number 1. So we can write down the simplification of equation number 1. V2 is equal to under root 2gh plus V1 square. This is equation number 1. Now at here we can apply V1 value. So under root 2gh plus A0 square Cc square V2 square divided by A1 square. Further simplifying the equation, and we can get V2 is equal to V2 square is equal to 2gh plus A0 by A1 no whole square Cc square V2 square. Now further simplifying the equation, we can get V2 square minus A0 by A1 square Cc square V2 square. Separate the similar terms V2 V2 at right hand side and left hand side 2gh. Now we can common out V2 from the equation. So we can write down V2 square is common from this to 1 minus A0 by A1 whole square Cc square is equal to 2gh. Now V2 square is equal to 2gh divided by 1 minus A0 by A1 whole square Cc square. Further simplifying the equation, V2 is equal to under root 2gh divided by under root 1 minus A0 by A1 no square Cc square. Now we have derived the equation for the discharge. So discharge is nothing but capital Q is equal to A2 V2. Here V2 is nothing but A2 is nothing but A0 Cc from equation number 2. A2 is nothing but A0 Cc, or from the area of Venn contra equation, A2 is equal to A0 Cc V2. So put the value of V2 in this equation. So we can get the discharge equation Q is equal to A0 Cc under root 2gh divided by 1 minus A0 by A1 no square. So here Q is equal to, further we can write the equation for your information purpose. Q is equal to A0 Cc under root 2gh divided by under root 1 minus A0 by A1 whole square Cc square. Now simplify the equation in the form of discharge. It means CD is equal to coefficient of discharge is nothing but CC into CV. For example, okay, what do you mean by CC and CV? In our case, CC is coefficient of contraction, CD is coefficient of discharge, and CV is nothing but coefficient of velocity. So we can write that the value of CV is in the form of CC into under root 1 minus A0 by A1 whole square divided by under root 1 minus A0 by A1 whole square CC square. This is the value of CV. Value of CV. Now we can further simplify the equation. CC is equal to CD bracket 1 minus A0 by A1 whole square CC square divided by under root 1 minus A0 by A1 square. So here this is equation of CC. The CV is nothing but the coefficient of velocity. Coefficient of velocity is nothing but V2 by V1. In our case, we have already derived this equation of V2 and V1 in the form of area. So V2 is nothing but under root 1 minus A0 by A1 square divided by under root 1 minus A0 by A1 square. This is the equation of V2 and V1. It is called the coefficient of velocity. CV is equal to V2 by V1. This is the equation of V2 in the form of area of orifice and area of section 1, and this is equation of V1 in the form of area and orifice. So like that, CC is equal to CD bracket under root 1 minus A0 by A1 square CC square under root 1 minus A0 by A1 square. Now as you know that Q is equal to A0 CC under root 2GH divided by under root 1 minus A0 by A1 whole square CC square. Now put the value of CC here. So Q is equal to A0 CD under root 1 minus A0 by A1 square CC square divided by under root 1 minus A0 by A1 whole square multiply under root 2GH under root 2GH divided by under root 1 minus A0 by A1 whole square CC square. So further simplify the equation, we can get CD A0 bracket under root 2GH. These terms are neglecting because it is the same term, divided by under root 1 minus A0 by A1 whole square. So CD A0 CD A0 A1 divided by A1 square minus A0 square under root. Here a1 is denominator, so we can multiply the a1, and multiplication of the 2gl is similar. This is like that. Further simplify the equation. So for your understanding purpose, we can write the equation like that. Here I can simplify this equation, so please focus here. CD A0 under root 2gh divided by a1 square minus a0 square divided by a1 square in whole bracket. So further simplifying the equation, so this is a1 in the denominator of denominator, so it is in the numerator term, so a1 is here. Okay, like that. This is the equation of discharge through orifice meter. Q is equal to CD a1 a0 under root 2gh divided by under root a1 square minus a0 square. Here CD is nothing but the coefficient of discharge, okay, of the orifice plate. This is called the equation of discharge through orifice meter. CD a1 a0 under root 2gh divided by under root a1 square minus a0 square. It is called the equation of discharge through orifice meter. Okay, orifice meter, discharge. Yes. Okay. Thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch these types of more technical video, then please subscribe our Techno Education Academy and also share with your friends.